Good everyone, my name is Graphics. In this tutorial, we are to find the limit of theta tends to 0 of 1 minus cos theta all over theta sine theta, right? Now, if you look the expression closely, you discover that if I should input the value of theta equals to 0 into this expression here, I'll be having 0 over 0, which will make it undefined, right? Because if you put 0 where theta is, we'll be having cos 0, and we know cos 0 is 1. So 1 minus 1 is what? 0. Similarly, in the denominator, if you put your value of theta tends to 0, right? It will be 0 times sine 0, and that will also give us what? 0. So we'll be having 0 over 0. This is just to show you that when you input your value directly by direct substitution, you'll be having 0 over 0, which is undefined. So it means that we have to do something to this expression to avoid this from happening. Are we communicating? Now, there are two things you can simply do. Either you use the L'Hospital rule to simplify this by differentiating the numerator and denominator, right? Or you factorize. Now, it is always better and more effective when you are factorizing. If you see a function is an expression that you can factorize, it's better for you to factorize it than using your L'Hospital rule, right? Because it earns you more mark. It's only when you don't have a direction that it is not factorizable, then you can use your word, your L'Hospital rule. So in this tutorial, I'll be making use of what? Factorization method in order to factorize this. So what I will do here is I'm going to rationalize with the conjugate of the denominator of the numerator, which is 1 minus cos theta, right? And the conjugate of that is what? 1 plus cos theta. Is that okay now? So the conjugate of 1 minus cos theta is 1 plus cos theta. So if I should do that, I'll multiply both the numerator and denominator, and this is what I'll be having. So the limit of theta tends to 0. For the numerator, I have 1 minus cos theta, then I'll multiply by the conjugate, which is what? 1 plus cos theta. All over, for the denominator, I'm having theta sin theta, I'll multiply by the conjugate of 1 minus cos theta, which is what? Multiply by what? 1 plus cos theta. So this is what I have here, multiplying the numerator and denominator by the conjugate of what? 1 minus cos theta. And what is the conjugate? You just change the negative to what? Positive. And if it is positive, you change it to what? Negative. And we've not done anything yet. Why did I say that? Because if you divide 1 plus cos theta by 1 plus cos theta, you'll be having 1 over 1. And 1 over 1 is still 1. And 1 times the expression given is still the same expression. So we are being fair here. We are maintaining equilibrium here, right? So now, if I move forward, if you look at what is in the numerator, we have 1 minus cos theta and we have 1 plus cos theta. Whenever you have anything like this, whereby you have the same thing multiplying each other, but they are the same, what I call it, the same binomial multiplying each other, right? And their difference there is plus and minus, just like you can see in the numerator here. We have 1 minus cos theta and 1 plus cos theta. We'll call it difference of what? 2 square. Is that okay now? So it means that if I should rewrite this expression, I'll be writing the limit of theta tends to 0 of, I'll take the negative expression, the one that have negative here, which is 1 minus cos theta, and I'm going to square both of them. So I'll be writing 1 square minus cos square theta. Either you say cos square theta or cos theta all square, we are saying the same thing, right? So this is difference of 2 square. So this I just wrote down will also give you this. Why did I say that? Because if you recall, a square minus b square will give you a minus b multiplied by a plus b. If you can remember that relationship there. So we move forward. Now, all over theta sine theta multiplied by 1 plus cos theta, right? Now, since we have this, there's something we can still do here. If you can remember your fundamental trig identity that says, recall cos square theta plus sin square theta is equals to 1. I believe you can remember that, right? Now, if I should make sin square theta the subject of the formula, I'll be having 1 sin square theta is equals to what? 1 minus cos square theta. And we know 1 is intersection 1 square. Now, what do you notice? The numerator here is similar to what I'm writing here. So what I'll do is whenever I want to write numerator, I'm going to replace 1 minus cos square theta by sin square theta, right? So this will now give me a new expression by writing it to be the limit of theta tends to 0. The numerator will now be sin square theta all over theta sin theta multiplied by 1 plus cos theta. They will be in bracket. Is that taken? Now, this is what we have here. We know very well that if I should write this out, right, I'll be having the limit of theta tends to 0 of, I'll write sin theta, right, over theta multiplied by sin theta over sin theta, open bracket, 1 plus cos theta. I have not done anything. I only rearranged. Because if you multiply the numerator, sin theta times sin theta will give you sin square theta, and theta times sin theta times 1 plus cos theta will give you theta sin theta, open bracket, 1 plus cos theta. So it's still the same thing. Are we together now? Now, the next thing we'll be doing here is that recall there is a relationship that says that whenever sin theta is divided by theta, or we say sin s divided by x, or we say sin s square divided by s square, or we say sin 3s square divided by 3s square, as long as the angle, the value in front of the sign at the numerator is the same thing as the value under the sign, which is the denominator, you'll be having 1 as your answer, right? So my sin theta over theta is 1. Are we together? So I'll be having the limit of theta tends to 0, 1, that is representing sin theta over theta, multiplied by sin theta in here 1, sin theta in here 1. So we're having 1 all over 1 times, open bracket, 1 plus cos theta. Are we together now? Now if I rewrite that now, 1 times anything will give you anything, right? So I'll be having the limit of theta tends to 0, 1 all over what? 1 plus cos theta. So if I input the value of theta in this given expression here, I'll be having 1 all over 1 plus cos 0, which will now give us 1 all over 1 plus cos 0 is 1, so I'll write 1 there. So my answer will now give me 1 all over 2, right? 1 plus 1 is 2. So therefore, the conclusion is very important. I will now say that the limit of theta tends to 0 of 1 minus cos theta all over theta sin theta is equals to what? 1 all over 2. So this is my answer. And if you have found this video helpful, please don't forget to like, subscribe, and also share this video. Thanks for watching.